Hey.
That was the Infinity War stuff. That's not the story of the lake.
You know what? I had a panic attack before watching it. Yeah, you really did. Bro, what
Things we need to know about, guys. Don't forget we're recording. Parallel lines and also perpendicular lines. We're just going to summarize that now. Okay, what it means. So, if I have a line, okay, and I tell you that one coordinate there is at 3, 5, and another coordinate up here, I'm not using squares here, I've just drawn a line is at 5, 11. Okay. What do you know how to do at the moment? If I asked you to find the gradient, how would you go about doing it? Yeah, Michael? Yeah, so I would do y2 minus y1. So y2 would be this one, that's y2. y1 would be this one. So we've got 11 subtract 5. And that's divided by x2 minus x1. Okay, so this is x2 and this is x1. So that's 5 subtract 3. Okay, and we get the answer 6 over 2. So the gradient m equals 3. So that's the gradient of that one. Just so you remember, y2 minus 1 is the change in y. Do you remember it being called the rise? And this would be the run. Rise divided by run. Okay, so in this case, what we do is we look at the line always goes from left to right like that. So the rise would be from the line, so the run would be like in that direction, and the rise would be, do we go up to the point or do we go down? So we always go left to right on the run, but the rise could be a rise or it could actually be a fall. Okay? So for instance, if we've got a line that goes this direction, and this coordinate would be -1, 5, and this coordinate would be 6, 19. We look at gradient m being rise divided by run. So what's the rise and run? So again, I start on the left. My run is always left to right. And do I then rise to that point or do I drop? A drop. So that means that because I actually have, so I have a run of, I'm going to do it the other way around, so my run is now how far? So from -1 to 6, so that's a run of? How do I get from 1 up to 6? -1 to 6, sorry. 7, isn't it? Yeah. Think about temperature. So my run is 7, and it's not a positive rise, so it must be a negative. So I go from Sorry, I've done this wrong, haven't I? Yeah, that doesn't make sense. Sorry, I wasn't thinking what I wanted to do. I actually want to go -9. Sorry, that ruined your notes. So what would be the drop? It must be negative. So from 5 to -9 is a difference of
5.
So I have to go from 5 to 0 is a drop of 5, and then another 9 to, so 5 and 9 make 14. So it's actually didn't.
I said 14.
-14. So that would make my gradient -14 divided by 7 is -2. So I have a negative gradient. And that's because the line is going down. So when we go left to right, we either go up or we go down. Okay. You see in both cases, you see the triangles? Now what is really important that we don't forget is what the gradient could represent in real life. Because you're going to have a criterion D assessment on this. So what could it represent? Yes, no. I'm going to say no. I get what you mean by hills do have gradients. But we talked about it as a what? Yeah, so the first one would be how much the water is increasing, which could be per minute, per second, whatever you want to use. The one that's going down could be like you've not left the tap on, but you've pulled out the plug, yeah, and the water is leaving. All right?
Actually, I believe.
Why? If the hole was the same size?
Because the pressure pushing down on it.
Potentially, you're right. Could be if you've got a big tub, it might go. But actually, that hole would only let a certain amount. If we simplify the situation, we would say the same amount can come out at the time. But I do get your point. Now, if I was talking about a hill, I don't know actually, it's not, no. I could be, if it was, do you remember we talked about it's a constant change? So it's the change of height of the water in the bath. If you were riding up a hill, it would be your change in elevation over time. So the line doesn't represent the hill as such, it's a mark of how high you are. And the going down would be you were descending, all right? But it could be lots of things. Can you give me another situation where we have a constant thing that goes up? And it's not just, maybe not over, well, with time is a normal one, but maybe not like a tap on or... From 0, the temperature would gradually rise until it hit that temperature. Could be, yeah. Constant heat, yeah. Age? Yes, as time passes, your age goes up. There's lots of things. Think biology. Think if you are growing a plant. Length of time, how high the plant grows. Would that be a... Do you think that would be a constant change one?
No.
Yeah, there's too many natural effects that would probably affect that. So a nice one, really easy one, is actually something we need to consider is what's called a cost model. Do you remember we talked about how much you owe a plumber if they come to your house? Yeah? So the gradient would be how much money you pay per hour. That's really important that you don't forget that. Right? The gradient is what is changing. Now, what we're now going to look at is where we start from and whether we can create a formula that expresses the line. What we need to do first is, let's discuss the parallel and perpendicular lines. So, parallel lines, what do we know about parallel lines?
They run side by side.
And what do we know about their gradients? Good. So parallel lines have the same gradient. So rise over run is the same. Right? So the same gradient means they're parallel. Yes, they'll never meet. If we were talking about two different cost models for plumbers and things, that means the two plumbers would never charge the same amount ever for the same time of work. Right, and then we talked about perpendicular lines. Now, how would you describe perpendicular lines? Intersect, but at right angle. So perpendicular lines. Now, you were doing this investigation. What about the gradients? First one, if one is positive, the other one has to be negative. Did you spot anything else? So if I say to you, line 1 and line 2, if I just tell you that line 1 has a gradient of 3, is there anyone that could tell me what line 2's gradient would be? Well, that would make it parallel. You think negative 3. It is not negative 3. It's negative 1 divided by 3. Pardon? It's a flip version, yeah. Your rise over run becomes run over rise for the perpendicular line. Right? It's not, if you just draw the lines, you'll see. So, for instance, if I give you two other perpendicular lines, right? If I tell you that line 3 is a gradient of negative 3 divided by 4. Are you happy with that? Yeah. So the run is 4, the rise is actually negative 3. What would the gradient of L4 be? 4 over 3. Remember, if one's negative, the other one has to be positive. Look at the directions they're going. L4 is going up, so it's positive. L3 is going down. So what it's called is perpendicular lines. Okay? We would call it this. This is important for you. One gradient is the negative reciprocal of the other. So reciprocal, the actual definition of reciprocal is when you do 1 divided by that number. So the reciprocal of 2 is 1 divided by 2. The reciprocal of 3 divided by 4 is actually 1 divided by 3 divided by 4, which just happens to be 4 divided by 3. So as you get better at your maths, you'll look into that a bit more. But the kind of easiest thing at the moment is to remember, actually, it's if it was negative, it becomes positive. If it was positive, it becomes negative. Okay? And if it's a fraction, the fraction gets turned upside down, flipped. It's not a fraction, it becomes a fraction with 1. Okay? So just to check then, I am going to just write a little table. All right? And I'm going to give you the gradients of some lines, and you are going to tell me the gradient of a parallel line. Right, parallel lines, and then you're going to tell me the gradient of the perpendicular line. Okay, so for instance, right, line L1, okay, has a gradient of 2. The gradient of a parallel line would be 2. The gradient of a perpendicular line would be -1 divided by 2. Okay, there's an example. Okay, so L2, I'm going to write as 5. L3, I'm going to write as -4. L4, I'm going to write as 1/4. L5, we're going to do -2/3. L6, I'm going to do 5/7. So there's a few for you to write down. So those are the gradients of the lines I'm giving you. I want you to state the gradient of any line that would be parallel or any line that would be perpendicular. So just the gradients. Right here, guys, so just to finish this off, hopefully you've got this. If it's parallel, it's exactly the same. So that should have been really quick and easy. Just to write, come on, pen. Give me a pen. 5, -4, 1/4, -2/3, 5 divided by 7, and so on. Okay? If it's perpendicular, first step, if it was positive, it is negative. It was negative, it is. Was positive, it is. Positive, negative. Then we could take, if it was 5, it becomes 1/4. If it was 4, it'd be 1 divided by 4. If it was 1 divided by 4, it would become -4. This one would be 3 divided by 2. This one would be -7 divided by 5. Okay? Okay?